Hi guys. Hi Oliver. Welcome to another Code Jam. It's been
Yeah,
a while.
yeah, it's always been a while, like.
I know, right? It's always been a while. That one got it.
Yeah,
So it's another fun Saturday and another fun jam. And today we would be discussing something decoupled backend with queues. And this was one of the ones that really equally interested me because what we try to achieve at Code Jam is standardized enterprise build, right? We want to do things where you know the enterprise standard of doing things. So in an enterprise, there is a lot of use cases of using things like queues, decoupling your API, and there are a lot of ways you could decouple your API, like a whole lot of ways. You could perform something like CQRS. You could do event-driven developments where you know you're not directly calling functions and you're emitting events. Those events could be queued up, and you could use something like Kafka, RabbitMQ, and all that kind of stuff for decoupled API. And it is very nice to have a decoupled system, of course, depending on your use case and what you're building. But I mean, this is what you're going to face in the real world, right?
yeah,
And so I'm super excited discussing this with you today with Kelechi Oliver. So before we get
yeah,
started, I would like us to have an insight to what we are going to be building. So Kelechi, please, can you take us on what we are going to be building today?
yeah. So I don't know if you can see the diagram, but this is what we're going to be building. We're going to be building two APIs. We already had the complete code ready, and once we get into the code section, we'll get to walk through that. But essentially, today we'll be building two APIs, communicating asynchronously with each other using queues. So
When you
essentially, what,
say,
what actually happens is,
sorry, when you say
yeah.
asynchronous, what do you mean asynchronous? Because
Okay,
I don't know what that
synchronous. So synchronous means when I ask for something, you give me immediately. That's
is.
synchronous because as I ask, you respond to me immediately. But asynchronous means when I ask for something, you go and do something behind. You don't give me immediately. You might tell me, wait, hold on, I'll get back to you shortly. All right. You
Okay.
go back and you perform the job. And later on, once you're done with the job, you inform me that look, I'm done with the job, and then you give me a response. Just like when you go to, for instance, if you go to an ATM machine to get money, you put in your card and you synchronously you get your cash immediately. But when you go
Yeah.
to a restaurant to order food, you place your order, and later on, once your order is ready, then the waiter will get back to you and be like, okay, your order is ready, and then they give you your order. Something like that. I don't know if I'm able to describe it using real life
So,
scenario.
so I mean, I think as a noob, I'll be wondering,
Yeah.
is that relating to concurrency? Can we say asynchronous tasks are concurrent? Like, how can you differentiate asynchronous to concurrency?
There is a difference in concurrency and asynchronicity. Like something concurrency has to do with performing, trying to handle different events at the same time, right?
Hmm. Yeah.
Asynchronous is now how you respond to that event. Are you responding to that event immediately, or you're queuing up, or you're trying to respond to that event later on?
Okay. Okay. Makes
Yeah.
sense.
So, but concurrency is you saying, okay, let's say I can listen to 50 people talking at the same time. But
Okay.
now, asynchronous depends, has to do with how I respond to those 50 people. I can just tell those people, okay, I've heard what all you have to say. Go back, I'll get back to you later. Or I can immediately respond to those 50 persons.
Okay. All right. That's cool.
So they're a bit different.
All right. That's nice.
Okay,
Okay.
so yeah, so for today's demo, we'll be having something interesting. First of all, identify a problem. In engineering, we want to first of all understand what the problem is before providing a solution. We'll identify a problem with something that has to do with a tax. Let's say, in this case, we'll be demoing with an export, PDF export, and we'll be creating two services. One, which is the existing service or the main service, which is the inventory API that handles the request from a user to export their PDF. All right.
Hmm.
And we'll see why it is not good to have that functionality inside the inventory service, and rather why it is better to decouple that using queues into a different service. Right, so we'll have a second service and a queuing system using BoolMQ, and then a second service that processes that export and then respond to that export request. And that's going to be our export service. As you can see in the slides, you can see that we have the inventory API, we have the queuing system in between, and then we have the export service. Yeah,
Okay. Thank you so much, Kelechi, for that wonderful explanation. And it means that this inventory service could apply to a lot of things and a lot of use cases. And the
yeah,
fact that we are doing something like import exports and we are doing a lot of decoupling, I mean,
yeah.
this is something you don't miss. So let's get started.
Cool.
Decoupled backend with queues. This is a very satisfying topic name, I guess. Yeah. So, what does queue even mean? So, a queue is a data structure used to store, manage collection of items where the primary operations are done in a sequence of first in, first out. So, I'm going to explain this. So, a queue is like, for instance, you have a batch of information you want to handle, right? And like Kalechi said, these things could be done asynchronously. So you don't want to handle them instantly, like I do this, I get this immediately. No, that is not your priority. Your priority is that you want to be able to decide on what to do with that information later and handle them when you are available to handle them. For instance, let's say you're listening to 50 persons and these 50 persons have communicated to you and you're like, okay, yeah, I will go and act on this. I'll go and think on this and give you a reply later. So you could have the 50 files in your decks and you start attending to them, be like, okay, this person said this. Okay, let's attend to this. You move it out. And that is when you have time rather than act on it immediately when you don't have time and when you have other things to do, right? And in this sense, I mean, you could have a batch of information come through yourself. You queue them up, you line them up, right, and use whichever queue whichever method you want to use, like first in first out, which is the FIFO, or the first in last out. And there are other data structure process approaches as well you could use to attend to this to this stack of information or this list of information you have with you, right? So what problem does a queue solve? Right? Okay, we've known what a queue is. What problem does it even solve? Why do I need to queue up my tasks? Well, you look at fault tolerance and reliability, which is one case queue tends to solve. So queue can persist tasks, making the system more fault tolerant. So you have
Yeah,
a system that, let's say you have a limited resources. You have a
yeah,
two core processor and you have, these very intensive tasks, right? If you decide to run your tasks synchronously, where you have tasks come in and you process on them immediately, it could be
yeah,
that your CPU is trying to handle something else or do something else under the hood. So why those tasks are coming? So 50 persons are sending you a message. You're trying to let me act on this, let me act on this, let me act on this, and let me act on this. So those 50 information, there could be cases where you lose data, right? You're like, oh, okay, someone is showing you like a batch of information. Hold
yeah,
this, hold this, hold this, and you're trying to catch all of them, right? You could, you're trying to catch and process. So there are cases where you're like, you've caught one, you want to process it, and you lose one, the chew on you. So Q tends to help you maintain fault tolerance. So if you're more focused on receiving information and keeping them somewhere where you could act on them later, you see that it improves fault tolerance in that sense. So if a worker fails to process a task due to an error or system crash, the task remains in the queue and can be retried whenever, right? And when until that task is retried and passed, it's not removed from the queue or the stack, right? It's
yeah,
persisted in the queue and until it's retried and there is a game, so it's not removed. So that way, if you try to perform an action, it fails, you don't have to worry yourself because you have a system that recovers from failures and retries again, right?
yep,
Now, load management and scalability. So queue systems act as buffers to hold tasks until resources become available. We explain this like, you have cases where your CPU is constantly trying to process something, probably an expensive query somewhere, and the system is not at the time very much available. It doesn't have the resources, or your RAM is maxed out or something. If you have a queue system, information comes, your system sees that, well, the CPU is currently busy right now. It queues it up and waits. Whenever the system is free of those resources, it starts processing those information. So by controlling how many tasks are processed at a time, queue help to manage the load, leading to improved performance and prevent crash due to resource exhaustion. So there are cases where your system is like maxed out. It becomes very slow, right? So
Yeah.
this is going to give you the worst user experience. Your customers are going to be complaining because why is this site not responding? Right?
Yeah.
Because you're trying to handle like 100 tasks in a second instead of handling in batches of 5 tasks per second, right? So you're handling 100 tasks in a second. It increases your processing time to like 100 seconds or 200 seconds instead of handling batches of five tasks per second, which is like in milliseconds or probably in microseconds, depending on your CPU speed. And we'll have asynchronous processing. Like Kelechi has explained, queue system lets application hand off intensive tasks to be processed later. So asynchronous means that, okay, you're not so keen on getting this and starting it immediately. You could get it and decide to process it whenever resources are available, right? So these resources could be processed later. And by this could be processed not by the main thread, or but by worker threads or by dedicated workers for this very task. So your main thread is not blocked, right? You have a system where your main thread is just free. Resources are coming in for like something like get me this user information. You still have a core system or a thread that is allowing you to get user information and do other things.
Yeah.
Whereas a dedicated thread is in charge of collecting tags and queuing them up and probably calling those tags one after the other and executing them. So that way you don't have a blocked process, right?
Yeah.
The main application thread remains free to handle user interactions or other tasks, maintaining a responsive system. And this can be seen sometimes if you've ever written React Native, you see that there are sometimes where if you're performing an expensive task, depending on how you've written your code, your UI is blocked, right? For instance, you want to do something under the hood and you're trying to, respond to your UI. The app is native, right? You're trying to do something, not native in that sense, but you have a kind of native like app and you're trying to do something else. You're trying to probably move a button or probably move a slider or something like that. But because something is processing under the hood, right, it blocks your entire thread, right? You can't move your cursor. So queues, by using queues, right, you could have dedicated threads that handle this kind of situation, and your UI is never blocked, and all those things are still free for you to, you know, have a smooth experience and not have a horrible experience.
Yep. Yep.
So this is like a simple diagram to illustrate what we explained, right? You have a sequence of priorities, right? You have an application, information comes in, and it's queued up. And depending on your queue priority, you could have a
Yeah.
first in, first out kind of approach. So information that comes in first is being consumed, right? It's sent out, processed, or sent out to whatever user, or depending on your use case, right? And this is a very simple illustration of that, right? So queues are not so rocket science. Of course, there are queues where you want to enhance your queue. You want to use there are queue systems where you want to enhance your queues. Use something like probably your RAM to have faster retrieval of information and all those kind of stuff. You don't want to max out your heap and stuff like that. There are things you want to do, and you want to make sure that you're using best case scenario. And in those cases, I would not advise you build your own queue from scratch. There are a lot of queue systems you could use, but there are simple cases as well where you want to have a simple queue for simple use cases, right?
Yeah.
And it's very simple, right? You could have a simple queue system, and it could just be probably a class that has a kind of storage. You can see this here, and what this does is like you have a class of a storage, and your constructor is like saying that, well, my storage is going to be wherever the storage is. So it's going to be, for instance, if you initialize this class with a bunch of information, that is going to be stored in the storage, right? So it's saying that this storage is equal to initial elements. So you're spreading that in a kind of array. So you have this array like form where you call those array one after the other. You perform operation like push and other kind of stuff. So you
Yeah.
could enqueue into it, So if you want to enqueue, you do, you call an item, the enqueue method. And what this enqueue method does is just it calls the storage and it adds to it. So it does a push, and this push just tops off, an item to the last item in the array. So that way you're going to have it as always the last item. And the queue, what the queue does is it checks if the queue is empty. So it does an if empty. So this does is empty. And what is empty does is it checks this does size, right? And the size chase the length. So that's not like rocket science. So size is like story.length. If it's equal 0, then it means that that queue is empty. And it goes ahead to console log or return undefined. So there's no item in the queue and you cannot dequeue from an empty queue. But if you want to enqueue, okay, we have already spent enqueuing. So if you add the queue, if you decree an item, it goes out from the queue. So it does. Let's say the queue is not empty, right? What happens is it goes ahead to say this is storage does shift, and what shift does is it just moves out the that's the first item in the queue, right? And that item is removed, if I'm not wrong.
Yep.
So,
Yep.
and you can see we have an example of what that is going to be like. If you want to, you could probably spin up a console log and try this out yourself. We're not going to try this because we have a demo we want to present. So this is how you could build a simple queue system for your JavaScript application.
Yeah.
And with that, this is what we've already shared, right? And this is what you're going to be building a small inventory application or an API that allows you to when you finish up your stuff, you could export a PDF and all that kind of stuff, right?
Yep.
So let's get started, right? We've talked a lot, and we want to get started into building and seeing how we can actually, you know, decouple our API with queues. Let's build.
Yeah.
So
Uh, okay. Am I starting?
yeah, you could start, Kelechi.
Okay, cool. That's a good one from Melody. It was very quick, knowing that we have a lot of things to do with queues today. And yeah, so I will just share my screen and we'll jump right in. Let me just bring
Okay.
this in. Yeah, just going to. Yeah, can you see my screen?
It's loading, so give it a sec. Yeah, I can see it now.
All right. So, guys, we've got the project on GitHub. So, if you go to GitHub and you want to follow along this, you can just go over to the starter branch. Over here, you have on the main branch, you have the finished product project, and on the starter branch, you have the where we'll be starting from. Okay, in case you want to follow along, and we need to add the link to.
Yep, I'll do that now.
Okay, cool. So yeah, so first thing, I already have the project in my code editor. So here I'm using VS Code, which is our de facto. So over here we have a couple of folders. It's typically a very simple project. We have the README files, and we've got a data folder that has the mocked data we'll be working with. Currently, we're using some technology. We're using Redis. Redis is the queuing persistent layer we'll be using for the queues.
Lechi, please could you zoom in a bit again,
All
just
right.
so we have. Yeah. All right.
Is it visible now?
Yeah, this is better.
Okay. I'm way covered up. Yeah.
Sorry about that.
Yeah. Okay. Is this not too much?
You could zoom out just one. Yeah, this is better.
Yeah, I think this is better. So I can also see myself. All right. So we've got Redis. Redis is the persistent layer we'll be using. There are different queuing technologies. We have something like SQS if you're using a managed queue service. We have other things. We have SQS. We could use something like Bool, something like Bool MQ. But for me, I've just been working with Redis and Bool MQ and also SQS. So in this video, in this demo, we'll be using Redis as a persistent layer for a queue, and then Boolean queue as a queue implementation. So Boolean queue relies on Redis to function. And then for our storage layer, we're using MongoDB, a document database. And then for our framework, we'll be using Nest.js. Nest.js is a Node.js backend framework. And we'll also be using Docker. Docker is a container runtime, or not orchestration, rather runtime. And we're using Docker. And here you've got a Docker Compose file. The Docker Compose file makes it very easy for you to spin up the external services, in this case, MongoDB and Redis. And also, you could also spin up the services we'll be building today, right? So here we have a diagram. The diagram just illustrates what we'll be building, which
Could you take a minute, Kelechi, and explain the Docker Compose, syntax and what that does for us?
yeah. So first, here we've got the Docker version 3.8. We've got some volumes which maps to my local directory here. We've got the Redis volume. So we're mounting my local directory, the volumes in my local directory inside the container, right? As you can see here, we've got a service here, which is the service running the MongoDB database. As you can see, the container name is MongoDB, and the image is actually the MongoDB image from Docker Hub, and we're indicating to restart the container always, and also we're passing in some environmental variable, right? So the first one we have here is actually the username, so that we can log into the database as we provision it. We also have a password. Okay, so this is just for demo purposes or for local development. If you're deploying this online, you want to make sure you're not having your password directly here. Okay, so but if you're working with this locally, nobody has access to your local computer, so it's okay to have your password here. And then here we're indicating the volumes. We're mounting our dot volume directory over here. Inside it, we'll have the MongoDB folder, and we're mounting that folder inside the data slash DB directory inside the container. So what this helps us do is we can start and stop the container anytime and not worry about the volumes, the data getting missing, because we're mounting that data inside our project folder. Okay, and then we're exposing the ports. We're exposing ports 27019. We're mapping that port to 27017 of our container. If you've worked with MongoDB, you know that by default MongoDB runs on ports 27017. So we're saying on our host machine we want to use ports 27019, and inside it we want to map that to the container port 27017. Okay, and then the next service we have here is Redis. We're still using the public Redis image here, and also we're indicating to restart the container, and we're also mounting our Redis folder inside the volume folder here inside the slash data directory of the container. This way, if we stop and start the container, or if we try to delete the Docker Docker Compose, like the Docker system container itself from Docker, our Docker desktop would still have our data persisted. Okay, and also we're mapping same thing. We're mapping port 6381 to the container port 6379. Okay, the rest of it is just if you want to optionally run the services we're building today inside the Docker container, you can uncomment these and do that. But since we'll be actively changing these files, we just want to run them directly so that we can have a watch on it, and when we change it, to automatically update. All right. I think I've done a bit of an explanation, even though that's actually outside the context of the video. But yeah, I've explained. We've run
Yep.
through the Docker Compose file, and next thing we look into, as I said, the data directory is just holding our mocked data, and inside here we have our services. We've got two services. We've got as from the diagram, we've got the export processor service, which I will come into later, and we've got the inventory service, or the inventory API rather. So in here, this is just a
Yep.
basic Nest.js project. As you can see here, the Nest JS CLI. We've got some package JSON. This is a node project. Of course, you expect to see a package JSON file. And we've got a couple of run scripts and also a couple of packages, dependencies rather. And one of which is important here is the Mongoose. Mongoose is an ORM, um, yeah, ORM or yeah, ORM for MongoDB. So we use Mongoose to like query MongoDB, add data, find items and all that. And also another one here is Nest JS BoolMQ. Nest.js has an implementation of BoolMQ, more like an adapter for BoolMQ. Okay, and also another important one here is the BoolMQ package itself. Okay, so as I said, BoolMQ is the queue implementation we'll be using, and as you can see here, this is the documentation for BoolMQ. It's a service that can be used in production. So if you have production ready application and you want to implement queue, you can think of using BoolMQ. As you can see, this is used by Microsoft and all other companies. Okay, so that's installed through npm here, as you can see, BoolMQ, and the rest of it are just normal. This is the main Mongoose package. This is the Nest.js adapter, and the rest of it are just normal additional dependencies. Okay, so we've got a couple of dev dependencies for TypeScript compilation and all that. I think I should just spare us that time and jump into some other thing. And in here, we've got a Docker file to just build this Next.js application, and that's it. Okay. And another important thing we've got here is an env file. The env file just has the port we want to run our application, the database URL. In this case, as if you remember correctly from the Docker Compose file, the MongoDB user was admin, and the password was password admin123. Okay, and our Redis is running on localhost, of course, and on port 6381. If I just open the Docker Compose file, you'll see that this is 6381. Okay,
Yeah.
and if I open up um, Docker desktop, you'll see that we'll have the service running here, the couple backend with queues, and you can see MongoDB and Redis running here. Okay, so I'm just trying to be quick because of time. Yeah, so let's go into the code proper. We're currently inside the starter branch, and as I said, this is a Nest.js project. So inside the source, we've got our main application code. Here we have the app. We have the main. The main is the entry point for every Nest.js application. All right. So, guys, if you're not writing backend with Nest.js and TypeScript, please do. It makes things easy. All right.
Yeah.
So, yeah.
I
So
think
this
we
is
have a video on Nest.js for those who are interested. You can go check that
yeah,
out.
yeah. We do. Yeah, so this is Next.js, how you bootstrap the new application in Next.js. We're starting the app and we're telling the app to start on port, starting our backend on port envs.port, which is any port we define inside our env file. Okay, so this is the main file, and this is where we're using that port here, and we're just using a logger to log the statement indicating that our service is running. Okay, and inside here we've got a couple of files. We've got the core file. The core file has some configurations like us exporting the envs. All right, using we're using env flow here to export the envs, and all these are very much self-explanatory. If you've worked in a Node.js project before, you're used to Node envs. And we're using schema validation with Joy. Joy helps you validate env schema so that when you start your app and you're missing some envs, you automatically get an error. Hey, this env is missing. All right, this is very beneficial. So your app don't start, and then during runtime, you notice that you didn't provide the correct env. Okay, so that's what the core folder contains. And then you have the database folder. The database folder just has schema, your Mongo schema. So this is how we declare a schema for MongoDB here. So today we're going to be demoing with an inventory. We're going to be creating a scenario of an inventory application that has stock items. All right. So that's what we have, a stock schema. And the stock schema has like a store ID, has a name of the item, has the cost of the item, also holds the quantity of the item, the expiry date, the created by, and the quantity sold. Okay, this is a very generic way of creating schemas with MongoDB and Mongoose in Next.js. Okay, so that's it for the database folder. The next is the main folder I'll be working on today, which is the stock folder. So the stock folder has our controller, which is how you, when you're working with Next.js, your controllers handles API requests and then forwards it to different services. Um, your backend services, and then your backend services to maybe your repositories for data queries. Okay, so we have our controllers. Is a typical controller. This case, we're saying we want to handle any request that comes to slash stock, and we're handling a post request. Post request has to do with somebody creating a stock, and we're handling slash list. So this is slash stock slash list. We're handling getting stock, a list of stock items, and also we're handling delete. We're handling export PDF. Now, this is
Yeah.
where we dwell on much because this is where we're trying to solve a problem. Users want to export a PDF of their stock, and their stock can be in thousands. So imagine exporting a PDF that has an item in thousands. That is a huge task to complete. And if you have huge amount of users making that request, your server is going to run out of resources. And that's why we need to handle this asynchronously by queuing those events and then processing it. And once we're done with processing it, we can find a way to message the user and be like, okay, your PDF is ready. This is an email of your PDF. All right. So this is where I'll be working on more today. So that's the controller. This is the module. In Next.js, you have something called modules. That's where you import all your controllers and your services and you make it available. So Next.js allows you to partition your application into modules. So you have different modules like an auth module, a user module. Depending on how your application is structured, you could have as many modules as you want, and each is act as a group of layers, making your application really easy to debug, to understand, and all that. Okay, so this is the module here. As you can see here, this is how we're importing and we're using configuring MongoDB Mongoose to work with Next.js. We have to tell Next.js that look, we want to make use of this particular schema, and whenever the schema is called, you should inject whatever thing we have. Okay, so I don't want to dwell too much explaining Next.js, but I want to focus more on decoupling that functionality I mentioned, which is inside the controller part here. But I'm just going to breeze in through all the files. Okay, so in here we have the stock service. So a typical Next.js application, when a request goes through, it first of all hits the controller, and from the controller calls the service. And as you can see here, we have the stock service getting imported, and we're calling create stock. And create stock is a method inside the stock service. As you can see here, we have the create stock. And what this will
Yeah.
do, this will just, create a new stock for you based on the input you passed, and that's it. The rest of it, the same thing applies to the get stock. The get stock will just execute a find and return all your stocks. All right, the delete stock, the same thing, and then the export PDF. Right now, we've not implemented the export PDF. That's what we're going to be working on throughout the rest of the video, the demo. Okay, so that's it for the stock. And inside the app module, we now need to tell Next.js about our stock models. And that's why you have the stock model here. We imported the stock model we have inside the stock folder here, and that's it.
Mhm.
And in here, before we make use of MongoDB, we need to tell Next.js that look, we're going to make use of MongoDB. And that's what we're doing here. We're importing Next.js module. We're importing Mongoose module, right? And also telling it the database, giving it the database URL to use. And also, since we're making use of BoolMQ, we're also telling SJS about BoolMQ by importing it here and also setting the connection parameters, which has to do with the Redis host and then the Redis port. All this put together makes it possible for our application to start up, for our Mongoose schema to be recognized, and for our Mongoose database to be known. Okay, so that's it for the project structure. I will go into the project structure is in inventory folder is almost similar towards an export processor. But once we're done with inventory folder, as we go on, I'll get to explore, we'll get to looking towards inside export processor. So right now, I
Okay.
would just move further, and I would start the application. So I would open up the terminal, and in here I will go into so I'll just delete this. Yeah, so I'll just go into the services, and I'll go into inventory, and I will start. I would first of all, if you're cloning this, you want to do yarn npm install first to install
Okay.
all dependencies. I'd already installed all the dependencies, so I don't need to run this. So the next thing you want to do now is to start the your Next.js application, and to do that, you run npm run start dev, right? As doing this would start the application. If you've worked with Node.js, before you can run that command, you must make sure you have a script here. As you can see, we have a script there, start there, which starts the application in watch mode.
Okay.
Okay, so as you can see from the logs here, we have our inventory service running here on port 7001. So let's go ahead and make a request to that port. So I'll go on my VS Code here. I've got this extension, Postman extension. So I'll click on it, and I would click on this part here. You can see that I've already got an endpoint here, which is going to localhost 7001, which is the port our application is running on /stock. So this is the endpoint to create a new stock. So I'll create a new stock, and I will say this is orange, for instance, and it's maybe $20. And I will just click send, and we expect this to create a new stock for us. And as you can see here, we've got a new stock created with an ID, and you can see the store ID, the name, and all that. I can copy this ID and go into my database and check that it's actually created. We'll go over here and let's take a look at the database. So real quick, I'm going to bring up the database right now, and the database is actually MongoDB Compass. So as you can see here, I've got the stock collection, and I can query by ID underscore ID, and with this, I can query this and click define, and you see that we've got our data written to the database. So that's good news. We're actually persisting our stock. All right, now let's move in proper. We've been able to create stock, and we've been able to check that the API is working. Now, the next part is actually doing the export. So let's assume we have a feature. We are asked to add export functionality to our API. All right, exporting. If you look at the table here, um, inside here, a store can get thousands of items in stock. All right, so it's not something you can easily handle directly for a given request. Right, so let's go into the controller. We have here an export PDF endpoint. You cannot really generate a PDF, export 1,000 or more items immediately because it's time consuming to generate a PDF. And for that reason, we need a way to actually handle that generation of PDF outside the request. We need to do that asynchronously. All right. So that's why we need queue. So if I come here and I try to add any implementation right now, there aren't any implementation. So if I go to the Postman collection here and I try to hit export PDF endpoint, you see that it's really quick. And I could also use a tool called AutoCannon to shoot this API. You see that that's really quick. All right, let's just do that. I'm just going to go into run an AutoCannon command. AutoCannon is a tool for benchmarking endpoints, trying to understand how fast an endpoint is. All right. So I'm going to hit an AutoCannon request to interact with this service in 5 seconds to send 500 API calls. And you can imagine this command simulates like 500 persons trying to make requests to your API. Right. So when I hit this now, within the next 5 seconds, this will be done, and you see how fast it is. Backend is able to respond because currently we're not doing much on that endpoint. You can see all the console logs coming out here. There is a lot, right? We're responding to that all fine. But once we add any implementation here to start generating PDFs, you will see that we'll be having failures. Okay, so I'm just going to go there down to the service and I'm going to bring this down. Okay, so let's just demo that. I'm going to paste in a function code to like try to generate a PDF. Real quick, just grabbing that.
Yep.
So I'll just go inside, create a utility function to do that. Um, I'll go inside the inventory service, inside core, I'll create a util folder. And inside it, I would have a file called generate pdf.cs. Okay, so please, if you want to really follow along with the code, just try and clone the repository.
Yep.
Okay, so I'm just going to
And
paste that.
you can equally check into the starter branch and
Yeah,
yeah.
so I'm just going to paste that in. To generate the PDF, we're using a package here called PDF Kit. It's a good package to generate PDF. So I'm just going to install that package inside the inventory project. So terminal. So I'm just going to kill this for now since and I would do npm install. Okay. All right. I've installed it, and this should go away. This error should go away now. So I need to next thing. I think I need to check there aren't any issues again. So I need to now use this method. So I'll go down here and I'll call generate PDF. And I need to pass generate PDF to arguments. I need to pass it the stocks, which is an array having all the stocks. And then I need to pass it a write path. This write path is just essentially the name of the file we want to save it with. So I'll just do like a find here, find all the stock for this store ID. So I'll just do stocks is equal to this dot stock model dot find, right? So this would return all the stock for this particular store ID, which is a lot, but I'm going to pass that array of stock to the generate PDF function, utility function, and then I'm going to pass in the name of the file. So for the name of the file, I'm just going to make use of I could make use of I'll just make use of I would say output.pdf, right? Just a name there, right? So once I save this now, and now let's try to hit the endpoint again. This would do a lot of havoc, right? So we've done that and we've saved. I'll start the service. That's the inventory service, and I'll try to hit that endpoint again.
God forbid we try to run 500 similar.
I'm trying to avoid that because that's going to clog up my although I use the same file name, so it wouldn't clog up my
Yeah,
system. It might just run error.
just replace it. Yeah,
Let's just see. That's why I'm trying not to use a random file name because that's just going to fill up my system with a lot of yeah. So I'm just
just
going to
yeah.
hit this. Let's see. And let's see what the latency is. You can see that there is okay, so I'm looking at the how many milliseconds it took. Let me just extend this a bit. So you see how many you can see the request seconds. You can see here is 6, here is
Right?
5,000, and you can see the difference like um
Six
uh,
seconds.
yeah, 6, this is greater. So like I think this is maybe the duration, about the request duration per second, right? So this is trying to tell us that like it's taking more time to actually like only few requests is getting processed, right? So this is taking like the latency here is 9 milliseconds, and this is 331 milliseconds, all right? Because here we had few things to do and here we had more things to do. And just imagine if this number keeps increasing, like you have like this is just 500, you have like 1,000 people using your application. You could imagine what that would be. So the average here, you were getting like 221 milliseconds, and here we're getting about 1,091. So you see that that process of trying to generate it with the same request, just to generate a PDF with the same request, it's not working. It's slow. The latency is really slow. So we need to decouple that functionality into a different service. Okay.
And something funny as well. I think some of the requests failed for the second one. If
Yeah. So let's
yeah,
see that. Yeah, you could see that 75 error timeout, 75 errors, right?
yep,
And here we have, I think
zero
here we
time.
have like 198. Just trying to know, understand the difference in the metrics here, but yeah, but I'm more focused. I think more focused on the latency here.
Okay.
Uh, yeah, so the latency here is greater. So here it took just for us to run this, it took like 9 milliseconds, and for here it's taking like 331 milliseconds, right? And average, you could see the amount it's taking. Average is taking like 43 milliseconds, and here it's taking 2,387 milliseconds. That's a lot of time. All right. And
Yep.
we're just doing 500. What if we increase this to 1,000 concurrent users? You'll see that with time, wouldn't be able to serve requests. We're not efficient in a way, right? Because the problem with this now is having something like this is blocking a user. Users are trying to export, just to export PDF. This process can actually block users that are trying to log into the application. All right, because export is taking so much of compute power. All right, so you want to make your application always make your application the way it can scale, and also it's not blocking like actions. You want to eliminate events that will take lots of CPU power to process, and also make it usable. At least a user should be able to log in and check other less taxing or perform other less taxing actions, right? So we were seeing the problem now that having something like this that is compute intensive, something that's generating PDF that is compute intensive inside the request response cycle or inside a synchronous process is it's not efficient. So for that reason, we can move this kind of process into a queue. And once we finish processing it, we can somehow notify the user, maybe through a webhook of, okay, your export is available, click this button to download it, something like that. Okay, so for that now we'll start introducing queues. Okay, so I'll just kill this here, and I'll remove this piece of code that does generation. We're going to move this inside a queue, and I'll go all the way to the top here, and also I will start importing the necessary files needed for us to implement queue inside this service. All right, so okay, I'm trying to get the. Okay, so I'm just going to we're going to inject the queue since we're in Nest.js. Nest.js does a lot of injection and all that. So we're just going to inject the queue class. So just
And dependency injection is very good, right? It allows a lot of things.
a
And
way. Some
first,
people argue about it.
I think it's good, right? dependency. I mean, if you tried writing tests when you have not done dependency injection,
Yeah.
yeah,
Okay.
you have to. Yeah.
Yeah. So we just imported the we just added and we just injected the queue inside the service here. I'm just going to import the packages to do that, and also we have something called the queue name. For you to actually do this, like you need like a name for your queue. Like in one application you could have multiple queues doing different things. You could have a queue to handle notification. You want to send email notification. You could have a queue to be processing exports, to be processing imports. So you want to identify those different queues using a queue name. And this queue export, PDF export, is just a constant file here having the text PDF export. Okay,
Okay.
so we've injected it. Next, we need to make use of this queue. We need to add something to this queue. All right.
Mm-hmm.
So we'll just do that, and that's very easy. Just a line of code all the way down here. So what this is doing is, since we're in a class, we can call this dot export PDF, which is what we injected here. And we can say add, we're adding a new item to the queue and we're giving it a name export and we're passing in a data. So how with something like queues, you have something like called queue producers and you have something called queues consumers. All right, the producers is anything that triggers or adds something to the queue, and the queue consumer is anything that picks something from the queue and processes it. All right. So in this case now, this doc.service is a queue producer. It's adding something to the queue. All right. It's triggering an event, adding something onto the queue, adding a job onto the queue to be processed. And in this case, for us to add something to the queue, we need to add some data or some payload. All right. And in this case, we're passing the store ID. So what we're intending to do is with the store ID, whoever or whatever service is the queue consumer can use the store ID and go to the database and fetch all the stock items for this particular store and use that to generate a PDF. Right. So we've just added to the queue. Now let's just check that this is working. All right. So I'm just going to clear this out and I'm going to start the service. All right. And I'm also going to open my queue visualizer. And in this case, I'll be making use of something called Redis Insight. So it's a cool tool if you're working with something like um, Redis, anything that has to do with Redis. And I told you that our queue implementation, Boolean queue, makes use of Redis behind the scene. All right, so I'm just going to open that up here, and this is the Redis instance we're connecting to, the one with the port 6381. Okay, so I'm going to open that. You see, I have a couple of items. I think these were added when I was testing. I'm just going to delete all these items. Okay, and I could just do a bulk action, and I'm just going to delete. And let me see if I've deleted. Yeah, so I've deleted all the items in this queue now. Next, let's try to see what happens when we add an item to the queue. So we've started the service, and now we're just going to call the endpoint to export PDF. All right, and I'll do that with Postman. This is Postman inside GitHub. Sorry, inside VS Code. Right, so I'm going to make the same request again. Sorry, this is the create stack, I guess. So this is the create stock, and this is the export PDF. So I'm going to send that request again, and let's look at the queue. And you see we have a new item in the queue, right? You can see that we have an item here in the queue called PDF export, and we have the payload we pushed inside the queue, which is the store ID. This is really important because this data payload is going to be picked up by the processing service and then processed. All right. And now this is entirely decoupled from the request response cycle. So no matter how we hit this endpoint, no matter how the number of users we have increased, this is not going to affect the functionality of our app. Other users can log in, other users can do stuff because we're not running the heavy processing inside there. We're going to be doing that at the queue consuming end. Right. So if we go over to we try to benchmark this now using something like AutoCannon, as I said, which is a benchmarking tool you can install using npm, and we try to hit this endpoint again. Let's now look at the latency. you see that the latency here is still as small as would expect. It's not in the thousands, all right? It's just 71 milliseconds, which is good enough. All right. Initially, when we did this test with the PDF generation inside the request response, inside here, the request response code, we were getting about 1,000 and something milliseconds for 500 concurrent users. All right, so let's go deep down. Now we've successfully added an item to the queue. Let's look at how we can process an item in the queue. All right, so to do that, we have a different service handling that. All right, so this service is called the export processor. This is just another Next.js application. Next.js application. All right. So this is just still almost similar to this. We have the source directly here, and we have all the database schema. It looks more like I'm replicating things here. But if you're using something like, if this was in a real project or an actual production project, we'll be working with something like monorepo to like share dependencies and all that. All right, but for the purpose of this demo, I just replicated it. So we have database and we have stock, which is still the same stock schema we had in inventory space. All right, we still have the same core. Inside core, we have a couple of configuration, which is just exporting the envs, all right, which I had explained. And we have a constant, which is where we declare the queue name here, which is still the same thing we had in inventory for testing. And then we have one important module, which is the export job. This is the queue consumer. This is what is listening for a new job in the queue and then processing it. When a new job comes to the queue, it's like, okay, I have some work to do and it's being processed. And the cool thing about a service like this is, depending on, you can actually scale this service individually. Like you can choose to just scale the export processing service if you're having more jobs in the queue. And you can also choose to reduce it depending on the mode of job you have. So this is not connected to the full-fledged application, which is the inventory API. All right, we're decoupling things and we're also making things we're making it possible for you to easily scale. So you can easily scale one service while the other service is there. Let's say you're having more users trying to export their PDF, maybe it's an annual, end of the year or end of the month, they need to take inventory for their stock. We have a different service handling that, and we can scale that independently. All right. And we also have our main service, which is handling normal users' requests like login, like checking of their buy and sales report and all that. Separate, we can scale that too, right? So we're decoupling our making scalability easy, all right, because this is running a different service. Okay, so right here, as I said before, this is just the consumer. This is what is listening for that queue. As you can see here, this is decorated with the processor decorator. Processor decorator is imported from Boolean queue, and you can see the name here of the queue we're listening for, which, as I said before, is just a constant variable that points to the PDF export. And you can see that each queue here in the queue already is appended with the name of the queue, right? Each item here, you can see PDF exports, PDF exports. All these things, the sorted set, the list, the stream hash, strings, and hash are all used by Boolean queue to manage the queue.
Yep.
Okay, so down here we have, as I said, the queue consumer is just extending the worker host, which is also coming from Boolean queue. And here we're injecting the queue. We're injecting the model here. We're using the Mongoose model, and this is the function that does the processing. This is the process function, method inside the class. Right. So right now, currently, we're just console logging job.data, and we're console logging the token of whatever job was added to the queue. Right. So if I start this service now and add something to the queue, you will see that we would have this console log getting printed out. Right. So right now we're only running the inventory service. Let's go ahead and run the export service. So for that purpose, I'm just going to split this screen into two, and I'm going to go into the the export processor. I'm inside the export processor, and I'm trying to make this a bit more visible. Okay, I'm inside the export processor here, and I can run npm run start dev. Okay, so now we are running. You can see that something happened. We got a couple of console logs. That's because we had already added some jobs to the queue. You can see that the export endpoint is still working, even though the queuing or the consumer was not up. This was what Melody explained during the slide. That you can resume jobs, you can persist the state of things, you can resume and process things indirectly. All right, so you can see that we just started the export service, and this picked up all the job we had initially added to the queue. And if we had added an implementation for processing these jobs here, we would have processed those jobs, right? So now we can see the queue is working. I'm just going to try to clear this, so we just have like end-to-end test of this. I'm going to start this again, and you can see the queue is running on port 7002. So this the inventory service is running on 7001. The queue service is running on 7002. Right. So I'll go over to the postman here, and I'll make a request to add something to the queue. So I'll click here and I'll click export. And as you can see, immediately I hit that export, that gets added to the queue, and then the export processing service picks it up and console logs this. So this is to tell us that our queue export service is listening to the queue and is processing stuff. Okay, so the next thing to do now is just us adding an implementation to what should happen when an item is added to the queue, which is the processing or the consume or just consuming the queue. All right, so right here we just have a console log. All what we want to do is we want to generate a PDF, and also possibly we want to push that PDF to S3, and want to console log the link to that PDF. If you're building this into an existing system, you might want to send an email to the user to like, okay, we've completely generated your PDF. This is the link to download it. All right, so we'll start to add that now. And yeah, so I'll just go over to the code and try to just add the piece of code that does that. All right, so I'm just going to add that here.
Okay.
So it's really simple. All what we have going on here is, first of all, we're doing the console log just to tell us this is working. We have a try catch block. We're now picking an item from the job. The job, when the payload comes, there's a data inside, and we have the store ID. We're going through the database to find all the stock items, and we're passing it. We're also generating a random name for the file name that should be used for the PDF, right? So we need to import the necessary packages. So we need to import nano ID. Nano ID is an npm package that just generates random ID. Okay, so we need to get nano ID. So we have nano ID here, and we have also the same method we used, which is the generate PDF method, or function in this case. It just takes the item, which is all the stock item we get from the database based on the stock ID. It just takes again a second parameter, which is the name of the PDF, and that name is just a random ID. And then we add a little await statement here just to allow it write the export information to a file on disk. And then we create a read stream here because we want to upload the file to S3. All right. So this is doing a lot. Even uploading the file to S3 also adds a bit of latency. So something like this, you want to push it to the queue. All right. So we have an S3 bucket here, which is this bucket here. So we expect to get files in here. So this is just AWS S3 for storing files. All right. So we also have, I'm just going to import that function to upload to S3. So this function just picks the buckets, depending on the bucket name, and the path you want, and then it takes the file stream and pushes it to S3. And then we're console logging the paths or the URL to that file here, and then we're deleting the file so we don't fill up our disk space.
Yep.
All right, so those are the changes, and I feel like I'm having an issue here.
I
Let's
think
just check.
think the curly braces are not matching. So
Yeah,
I think you could
that
remove one.
one really. Okay, yeah. Yeah. So we have that done. We now have added a processing layer for our queue, which is just taking an item in the queue and then processing it. So now let's
Yep.
test things. Let's try to generate this and let's see how it goes. Okay, so I would love to run autocannon for 5,000 concurrent or 500 concurrent user, but that's just going to fill up AWS. But let's just test this with one request. So I'll go over to the Postman here I have for export. And I'm going to make another request. And you see we've generated. If you look at the logs here, I'm just trying to open up my screen a bit. So if you look at the logs, we've successfully generated a PDF. We've also uploaded the files, and this is a link to the file. All right. So if you copy this link and you paste it in the browser, the PDF file will just be downloaded to my file system. And also, if you go to S3 and refresh, you'll see we have a new PDF here. So this is cool, right? We're not blocking the request response cycle. I mean, when a user makes requests, we're not blocking that process. We're handling that job in an external system, and then we're communicating back to the user, maybe in form of email, or maybe if you're depending on your application, it could be webhook. All right. So I'm
Yep.
just going to run another autocannon request, and I pray we don't blow up our AWS account. But
We
yeah,
could try like 100 items or something.
okay. I'm just going to do that, and let's just yeah. So let me just open up the PDF first. So I'm just
Or
going to
maybe we
open up.
could try 500 and delete them all later.
Yeah, we could. Yeah. So I just want to open up the PDF so we could just see what the PDF file is, how large the PDF file is, and
Okay.
yeah.
The
So
one
this
you
is
down, the one the system download. Oh yeah, this is.
yeah. So can you see my screen?
Yep, I can see a screen.
Okay, so this is the PDF. You can see how I don't know how many documents are here. Let me just yeah, there are lots of documents in here, right? And lots of documents in here. All right. So this is just for few thousands, like 1,000 items, you know. So generating this is just going to take a lot of time. All right, so let's try to also benchmark what we've done. We've seen the PDF. This is the PDF. As you can see, this is store. The store ID was store 123. From
Mhm.
the request we made, you can see store 123. And from the request we made here, you can see from the logs here,
Yep.
you can see that it's actually store 123. All right,
Yep.
store 123 down here. You can see that here. Okay, and this is the PDF name ends with QN, and you can see that here ends with QN. So this is the exact PDF we just exported. Okay,
Yep.
so let's go over and do some benchmarking. So initially we had an average latency of 71.63 milliseconds. Let's try to do this again with the same request. So when we do this now, you will see that let's look at the logs. You can see that this has finished processing the request, all right?
Yep.
But this is gradually going through that queue and picking out items one after the other and processing. Once it's
Yep.
done, pushes it to S3. So the moment we're refreshing here, those items are getting added, all right? The more we're
More like
refreshing, those items are gradually getting processed. So this is what we mean by a decoupled backend, right? It's not tightly coupled to the request that, okay, as a user makes the request, you're like blocking things, and the next user trying to just log in is being blocked from doing anything. And as you can see here,
I
you can see that file getting written and all that. Yeah, Melody.
I think we can try something fun. We could kill this instance right now and try to restart it. And I feel
Okay,
it's going to,
so
yeah,
let's just kill it. And we've killed it.
yeah, you could clear the
And
screen.
yeah, let's clear the screen. And now let's start it again to start from where it stopped.
Yeah.
So yeah, started from where it stopped.
And that's the beauty of, having things queued up. You know?
Yeah, it's your persist state and you can gradually process things. You don't lose anything. Like if you're building a payment gateway and you don't use queues, you
You're
just
killing
be
yourself. Yeah, what more can I say, right?
you just be losing people's money because something can happen. A network request can just go bad. Your data,
Yeah,
like I mean, anything can happen. So you want to make sure you're queuing things and persisting them and having like a dead letter queue where if something is not getting processed after three retries, you queue it up for reviews and all that. So these are cool things to do when you're building backend applications that should scale and that should handle more concurrent requests. You can see that as this thing is going on, we can do several other things with the main application. I can actually
yeah,
go to the Postman here and I can try to create a stock. You can see I'm comfortable creating a stock. My experience is not impacted. The latency is still very fast. Like this is way so fast, right? You can see I'm getting a response immediately because we've queued that process and we're gradually processing it with a different system. So this is the importance of queue. This is why it's necessary for you to think of a good use case or find potholes in your application or things you can handle asynchronously by other services. And that's it. So I know I'll be getting a couple of questions from persons who already have a very huge application with lots of dependencies, a monolithic application, and you'll be asking me, okay, how do I create a separate service for this? Well, the good thing is you can gradually migrate your services. That is, you can still in the same monolithic application have queue in place, all right?
yeah,
But the only problem you'd face is you cannot. The only problem you face you cannot actually scale each service. So you
yeah,
cannot say you want to just kill your queue processor. You have to scale the entire process. But the benefit you get is you can actually handle asynchronous requests. So you'll not be blocking your main application, right? Because you're pushing it to a queue and then another function or another module in your application is handling that. All right. So you're not blocking the entire request response cycle, but you cannot scale individual service. All right. But if you have the luxury of creating a different service, you can push all your jobs, all your huge or time-consuming compilation or implementation or whatever that takes time into a different service, and then you communicate, you connect the that processing service to the producing service using a queue. So this is it, and
yeah.
this is
I
the
think with
whole.
instance or one solution where you could try to kind of decouple
Yeah,
things into worker threads. You could have worker threads and you have a main thread that is not being blocked. I mean,
yeah.
you're still not being able to scale, your service. You're limited to the resources you have, but that could still help you in such a way that there's no blocking kind of, you don't
Yeah,
have that. Yeah, your main
yeah.
thread is not blocked.
The problem with that design is persistence. You cannot really persist the current state of your worker threads. Like if your server happens to crash, you've lose that state. All the things you've actually because those things are happening in memory. From what I've used in Node.js or using spinning up child processes, they're actually in memory. So if your main Node.js application dies, all the worker threads are actually going to die.
No, for sure, definitely.
Yeah,
But I mean, if your items are still being queued up, right, you could always
yeah,
spin them up.
yeah, yeah.
Okay. Uh,
So that's it. We're blowing up our like we had 5,000 concurrent users, so there'll be a lot of uploads happening here.
I can only say I'm sorry for Kelechi. I mean, you have to wait it out. Or anytime you spin it up, you're going to get them. Or you could
Yeah,
clear Redis. You could just, clear a
yeah.
Redis cache. But
So yeah, so that's it for these guys. If you want to, you can go to the main branch and look at the codes and look at the things we tried to demo. I know we're rushing a bit. That's because we have just a very short time to go through this, but we needed to cover a lot, which was the main part of it was actually demoing the part where we get to decouple the export PDF export functionality. So that's it for me, Melody.
yeah, I don't think it's rocket science going through the code. Take our time, look at the code, and I mean, this is Nest.js. If you're used to the traditional Node.js, it's going to be a bit of it's going to be a bit of difference for you looking at the Nest.js. architecture for the first time. But we have a video on Next.js which could guide you through, and there are a ton of resources out there. There's the Next.js documentation and all that kind of stuff. The idea we're trying to demo is, the essence of decoupling your application and the essence of enqueuing things, like using the queue system and the importance of that queue system. So go ahead, build your applications, throw in some queue there. You could even do something like, using something like queuing up emails. For instance, when sales wants to do some marketing to customers and all that kind of stuff, and you have like, let's say you have 1 million users, right? You can start sending them. You're definitely going to have instances where emails are going to fail. You're sending like 1 million users certain email and stuff like that, or probably even 1,000 users, your email might fail. But when you queue these things up, you can always, execute those emailing whenever your resources are available, and they would definitely happen when resources are available. So, for instance, we had to restart the server, we had to shut down the server, restart the server, and because everything is in a Redis cache, it's being persisted. The whole thing had to restart, and we still have our queue calling, processing, PDF and all that kind of stuff. So
Yep.
yeah, I think there is not much to say, but we are trying to create these wonderful videos for you guys, and it's a vote of confidence to us if you're going to please comments, leave good comments. You could criticize us as well. We accept criticism. Like the video if you like it, right? And of course, subscribe to our videos. That way, we know that we are not just we are trying to do something that is impacting someone there or someone is finding useful, and we will keep doing these awesome jams and giving out this awesome content to you guys. So that is all from me. If there's nothing else from Kelechi, I guess we'll see next jam, right?
Yeah, that's all for me. Thank you, and see you next jam, same time, same channel.
Yeah, same time, same channel. Bye, guys.
Bye.